Hello, everyone. Welcome to the March edition of DC604. We've got a web application security workshop with Kevin today, and without any further delay, Kevin.
Yeah. Thank you very much. I'll start sharing my screen. Okay, so I will share the screen. All right, everybody, can you see my lovely treescape there? Well, you can't really reply, but let me...
People can chat.
So I'm going to, first of all, I'm going to introduce myself through my scuffed PowerPoint presentation. Scuffed PowerPoint presentation means that it's actually a PDF. So today we're doing Shut the Front Door, web app authentication and security workshop featuring Practitioner Labs. Okay, so let's talk about me, your host. My name is Kevin. Online I go by Shy Hat. I'm a student of ethical hacking, and I am now entering my third year of study for cybersecurity. I am a largely self-taught individual. I didn't go to school to learn cybersecurity skills. I mostly learned online and through blogs and YouTube videos. But I still consider myself a student. I'm learning new skills daily. Okay, so let's talk about tonight's workshop. Tonight's workshop is Shut the Front Door. We're talking about web application login page flaws and how to exploit them. Most web applications have a login page. It's quite common, but logins written without secure coding in mind are often vulnerable to exploit and abuse. So tonight we're going to explore the use of the Burp Suite proxy software. More specifically, the Intruder tool, and we're going to work through some common authentication issues. Okay, and what we're going to do is we're going to identify what aspects of the login page are vulnerable and how we're going to mitigate these issues. Okay, so with that said, let's get ready to start. We're going to start up our Burp Suite program, and we're going to, if you need to a guide for the workshop, you can find it at this address right here. I'm going to drop the address in the chat one more time.
I just posted it.
Oh, thanks. Okay, so let's get ready to start. If you have not started up your Burp Suite program already, I'm going to do it right now on stream. Okay, so when Burp Suite starts up, you're often going to get this screen right here. What we're going to do is we're going to start a temporary project. We're going to click on Next. And we're going to use the Burp Suite, the Burp default. So we're going to click on Start Burp. Okay, so can everybody see the Burp Suite? Oh, I need to open up my chat. Hold on. Okay, so can everybody see my Burp Suite window? Type 1 for yes. Okay, so everybody, the first thing we want to do after we open up Burp Suite is we want to go over to the proxy tab here. So the proxy tab is right here. We're going to click on that. And we're going to hover over this button right here. Intercept is on. When intercept is on, it's going to prevent web pages from resolving because it's going to intercept the request. We want to toggle that to off, so just click on that and click that to intercept is off. And then we're going to open up the Burp Browser, which is the browser that's going to be to have all of their requests proxied through Burp Suite. So we click on Open Browser right here.
So just to be clear, Kevin, Burp includes a built-in browser.
Yeah, Burp includes a built-in browser. It's a very handy feature. It used to be that you had to set up Burp Suite to work with your with another browser, but this way it's a lot more convenient because you don't have to set up like set up certificates and stuff like that. So from here, after we open up our browser, we're going to go to the first lab that we're going to tackle, which is lab username enumeration by different responses. I'm gonna paste the link for the lab. Oh, just remember to copy the entire thing. It seems to have cut off a little bit. Okay, so I'm going to go there myself inside of the Burp browser. Oh. What happened? What happened there? If somebody has the correct, it might be because there was a space included there. Let me try that again. Okay, so I'm going to just go to the port sitter site, and then I'm going to search for the lab. The first thing we want to do is let's see, we can go to Academy, right?
Yeah, if you make the screen or the window bigger, the Academy link is going to be in the top bar, or maybe it's in the menu. Yeah,
okay, so
there
so
we
we
go.
just go to Academy. And Academy home. Let's see. Let me.
Mark posted a new link and it seems to work, at least for me.
Okay, sorry. Let me
yeah, there might have been a space after the dash there.
Okay, yeah, sorry about that, guys. Okay, so we're here. So this is the first lab we're going to be tackling tonight. Username enumeration by different responses. Okay, so let's read the lab description. This lab is vulnerable to username enumeration and password brute force attacks. It has an account with a predictable username and password, which can be found in the following word lists. So we've got 2 links here, candidate usernames and candidate passwords. We're going to be using these all throughout tonight's labs. So I recommend opening up these in your browser, and when you're ready, we're going to access the lab. So everybody, if you're ready to click on the access the lab link right here, please type 1 in chat. So I'll just type 1 here. And if you'd like us to take a minute to wait for you to get to this point, you can just type wait in chat right now. Mark Cohen would like a martini. Wow, wouldn't we all?
If anybody needs help at any point of time, just post something in chat or unmute yourself and ask a question, and either Kevin or I will help you out.
That's Burp Suite Pro, says Ryan. Jess says, wait, where is the lab located under Academy home right now? Okay, so I'm going to paste this link in chat, and I'm going to paste it there, and that should work. So Charmeleon Jess, if you would just click on that, you need to log in order to access the lab. So if you're not logged in right now, please log in. Okay, so with that, we're going to click on the Access Lab button. And so if you're not logged in, it'll prompt you to log in at this point. So here we are faced with a lab environment app. Okay, Dana is given some good advice. Make sure you grab the usernames and passwords and put them in files so you can load them. What you can also just tab over to them and copy the entire list as you need it. Whichever way works for you. So when we're in the lab environment right here in these authentication labs, what we're going to want to do is going to want to try to log in to the app. Go to the login page, my account, which is right over here. So we'll click on that. And from here, we're going to give some credentials for to get a failed login. It's just something so we know. So I'm going to type in test username, and for the password, we're going to type test password. And we're going to try to log in, and it's going to read invalid username. That's okay. What we can do is we can go to the proxy, to the Burp proxy tab under the HTTP history right here. We're going to find that request that just failed there under method. So we're going to sort by method. So just click on the method column right here. And we're going to go down to where the post requests are. And we see that the last post request over here is to the URL of login. So we're going to click on that. And it's going to show us the information that we presented in that request over here and the response. So what we're going to do is we're going to use this request as a baseline for our brute force username attack. So what we can do.
Kevin, just there's a question about setting the target to basically reduce the noise in the history.
Okay. So Dana asks, Kevin, would it be useful to teach how to set the target so they can reduce the noise in proxy history? Yeah. So what we can do is we can find the host in the request over here, and then we can highlight this. And then we can right click on this, and can we, wait. Okay, so we're gonna highlight this, we're gonna copy it, and then we're going to go to scope, right. So we're gonna go to target, and then scope, and then we're going to add to scope. So include in scope, add a new item, and then we're going to paste our address in there. And it's going to say you have added an item to the target scope. Do you want Burp proxy to stop sending out of scope items to the history or the Burp tools? We're going to click on always take the same action in the future over here. And we're going to click on yes. Okay, so this lab environment, that's the only one that's going to be included in the HTTP history. Okay, so that out of the way. We're going to go back to our proxy HTTP history. So here we have our login request. So we're going to right click, and we're going to send this request to the intruder. So click on that. And then we're going to click on the intruder over here. So this is where we're going to set up our brute force attack with the Burp intruder. So the first thing we want to do is we want to clear all the fields over here. So what we're doing here is we're going to set up a parameter that's going to be fuzzed by the Burp Suite intruder. So what we want to do is we want to figure out which username which username exists in the system. So under here in username, where it was previously test username or whatever you put in, we're going to highlight that. And then we're going to add that as a payload position by clicking on the add button over here. So click add, and you'll see that the parameter value has been outlined with these little snaky characters right here. And the next thing we're going to do is we're going to set up the payloads. So from positions over here, we're going to click on the payloads tab. And in payloads, we can keep everything as is here, but we're going to grab the username list. So wherever you have your usernames, so if you don't have this link right here, I'm going to paste it in the chat for you to use. Mark Cohen says, mine already had those characters prior to hitting add. Mark, what you can do is in the positions tab over here, what you want to do first when you hit the payload positions here is you want to hit the clear button. So you want to clear all the markers. So Burp Suite likes to highlight anything that might be interesting to add as a payload position, but we're going to clear all of that so that we don't have anything in the way. And we're going to just get the username value right here. We're going to highlight it, and then we're going to click add.
Yeah, so, I think it's basically Burp tries to guess what you want to fuzz, but in this case, we're only interested in fuzzing or like brute forcing a single field, and that's why we need to remove all the other guesses from Burp Suite first to basically mark what needs to be changed.
Right, right. So yeah, so we're just trying to figure out what usernames exist in the system right now. So we're just going to fuzz this one value. So once again, we're going to go to our payloads over here. So inside that list, you can grab all the usernames from that list, and then copy that. And then back on the payloads options over here, we're going to choose paste. So that means that that all the usernames from that list are going to be tested for by the Burp intruder. Okay, so those are the only two things we need to set up for this particular lab. Let me just double check. Yeah, I think that's it. And so the last thing we're going to do is we're going to start our intruder attack. So we're going to click on this button right here, Start Attack. It should be at the top of the window. Click Start Attack, and it'll say that the Community Edition is intentionally slow because they want you to buy the Pro version. So just click OK, and you'll see that that all of the usernames are being fuzzed for this particular attack. What we're interested in is the length of the request. So if the username is valid, it's going to return a different message. So what we want to do is we're going to click on the length column right here, and eventually one of the payloads is going to return different length than all the other ones. So if you're currently using the intruder tool for an attack, please type attacking in chat now, like I am going to right now. So we got a hit. So let's just go up here. So so the payload that received a different length response for me is add server, but every lab environment is going to have a different vulnerable username. So you're not necessarily going to get the payload add server for your lab. So if we highlight this one right here, it has a length of 2986 as opposed to 2984. If we click on the response right here, click on the response, and we go down, when we scroll down, you'll see that it says incorrect password, whereas all the other requests say incorrect username. So this is a classic mistake that people make when they develop web server login pages. The correct response when a login request fails is incorrect username or password. And that's a simple enough thing to correct, but in this case, this allows us to determine which username is valid inside of the lab. So everybody, if you manage to figure out which username is on the system, please type in chat username get in chat. Okay, so yeah, this might take a little while. So we'll just wait until the attack finishes out. We've got 30 more, 25 more requests to go here. Burp Suite Community Edition is a bit slow, so it might be that you might get to the end of the list before you actually get your hit. So we'll just wait a little bit. If you're still scanning for your username, type not yet in chat now. Okay, Mark Cohen says net yet, nice. Dana says things like Burp Suite Collaborator though is where Pro is also good and active/passive scanning. I fully agree. While I was briefly working at an InfoSec company, I had access to Burp Suite Pro and the Collaborator. Sorry, Gabe was answering. Okay, no problem. But yeah, there are some labs in the Portsawyer Academy which can only be solved if you're using the Pro version, which is kind of unfortunate. Okay, so Mark and Yan, did you get your username yet? Okay, Yan got the username. Nice. Okay. How do you pronounce that name? Is it Quinn? I'm sorry. There's Quinn. Okay. Thank you for letting me know. Okay. So everybody, let's move on. If you haven't gotten it yet, I'll leave a little gap for you guys to catch up a little later. With your request that got the alternative length message, what we want to do is we want to send that to the intruder. We'll right click that, and then we're going to send that to the intruder. And then we're going to, once again, we're going to clear all of our, we're going to hit the clear button so that all of our payload markers are cleared. And we're going, instead of the, so the username, oh, we know that one. So what we're going to do is we're going to fuzz the password. So under, after password equals, we're going to highlight this value, and then we're going to add that as a position marker. And then we're going to go to our payloads tab. And we're going to paste in our passwords. So I'm going to paste this, this in the chat now, in case you don't have it handy. So what we're going to do is we're going to copy all the passwords from here. And we're going to copy that. And then we're going to hit the paste button over here. And then we're going to repeat the attack. And we're just going to start the attack. And then press OK. Okay, so guys, if you've started your password attack, please type password attacking in chat now. Dana's quick. He's on top of this. Password attacking. Okay, so this time we're not looking for an alternative link. We're looking for an alternative HTTP status code. So in status, click on the status, and it's going to let us know when there's a different status aside from 200. So the incorrect logins all return a status of 200, but the correct login and the password, the correct password is going to give us a different HTTP status, which we'll see soon. Dana says, length will work on this one too, but your right status is better practice. Thank you very much, Dana. Rustum says he got a 302. That is the correct status we're looking for. So whichever payload gives you the 302, that's going to be the correct password for your particular lab instance. So I haven't gotten mine yet because the passwords and the usernames are all randomized for each lab. Back says, why is it a common case for password fuzzing tests? So this is a lab environment. It's for educational purposes mostly. So this is just a list of very common passwords that people might use. It's by no definition an exhaustive list, but it's a list that we're using for education purposes here. Unless you're asking another question, Max, in which case please elaborate on your question. Oh, Matt says we're looking for a 302, not lengthened password fuzzing. It is often the case that a successful login will return a different HTTP status code. So it might be that all the other ones return a. It's actually quite common that that a successful login is going to return 302, which is going to redirect you to another page.
Yeah, so when you log into some website, it usually redirects you to like a home page or a dashboard or something like that, and that's the 302 response. So like the page that handles authentication, when the authentication is successful, it will punt you to the page that you usually would go to as your first page.
So Mark comments that this activity, the fuzzing attack, could trigger account lockouts in the real world. That's correct, Mark. And we're actually going to be coming across this kind of scenario in some other labs that we're going to be running tonight. Dana says you can get around account lockouts by using Burp macros and delays. Yeah, we're going to be we're going to be covering a couple of these evasion techniques during tonight's lab, so please look forward to that. So I have not gotten my correct password yet. So everybody, if you have not gotten your correct password yet, please type "not yet" in chat, just like I'm going to do. Oh, here we go. I got it. Okay, so Harshan says not yet, and Alex says not yet. So Harshan and Alex, please. Okay, so Harshan has got it, and Harshan, I hope that's the correct pronunciation of your name. And oh yes, nice. I'm on it today. So Alex, when you get yours, please let us know. We'll wait for maybe 30 seconds more. So if we click on the request that got the 302 status, and we go down to the bottom, we can see what exactly is the correct username and password. It's going to be different in each lab environment. For me, it just so happens to be username ad server and password Dallas. Okay, so everybody, so let's solve this first lab by successfully logging into the lab application. So I'm going to go back to my lab application here in the browser, and I'm going to type in ad server, and password was this one, and I'm going to log in. Let me try that again. Ad server. Okay, so I've successfully logged into the My Account page, and it says right here that I solved the lab. So everybody, please do so according to whatever username and password you found. If you managed to get this this banner right here, congratulations to solve the lab. Please type victory in chat now. And if you need a little more time to catch up to where we are, please type "wait a minute" in chat. Okay, that said, I'm going to close out these windows right here. Just so there's a little less clutter. Mark Cohen says Anthony's buying everyone drinks. If only, yeah. Okay, so let's take a minute to talk about what exactly was vulnerable in that particular lab. So in this lab, there were differing server responses depending on whether or not the username or the password was valid when the login attempt was made. This is bad practice. The response message should be username or password was incorrect or something to that effect. Yeah, there should also be brute force protections in place, but we'll be covering some of that in the later labs. So that said, if you're ready to move on, please type "move on" in chat now. Move on, move on, move on. Okay, so everybody, the next lab that we're going to do is the 2FA simple bypass lab. I hope this link is correct. So it should be that link. So I'm going to paste that link in. And this lab is the 2FA simple bypass. We're on our second lab of 7 for tonight. Let's read the lab description. This lab's 2-factor authentication can be bypassed. You have already obtained a valid username and password, but do not have access to the user's 2FA verification code. To solve the lab, access Carlos's account page. So we've been given credentials, Wiener, Peter, and we have access to our victim's credentials, which is Carlos Montoya. Okay, so everybody, let's click on Access the Lab right over here and start our lab instance. Okay, so the first thing we want to do is we want to get a, we're going to try to log in. We've been provided credentials for this lab, both for ourselves and the victim user we want to access, whose account we want to access. So click on the login page, my account over here. Rustum says, should we reset Burp Suite before starting the new lab? No, we don't need to reset Burp Suite before starting the new lab. Dana says, if you decide to set scope, you need to reset your scope when you go into the new lab. And you might want to flush your history by clicking on HTTP history and selecting clear history. Okay, so let's do that. So in the proxy, HTTP history, clear history, where is that option? I usually don't do this, so I'm not exactly sure. Dana says,
Kevin,
right,
just in the middle where you see all the individual log items, right click on any one.
Yeah.
And then go down to clear history.
So right click
down a little bit. Yeah, you're there. It's in the menu, just a little down, a little more down.
History, okay.
There you go. That's going to clear your history. And then you're going to want to go into your target scope and change it to the new server, because each one of these labs is actually using a different server.
Okay, so what we do is we capture the URL, and then we go to target, scope, and then we remove our old lab, and then we add our current lab. And so that it should record only traffic from this lab. Okay, so once again, we're going to go back to our login page, and we're going to use the credentials we were given, which is Wiener and Peter as the password. And click login. And it's going to ask us for our 4-digit security code. But before we think about the 4-digit security code, let's take a look at the HTTP history. So we're going to go back to our proxy, HTTP history, and then there's going to be a post request to login. So here we see our request, and we scroll down to the bottom. We supplied Wiener and Peter. And in the response, we see here that that a cookie was set. So not only was a cookie set, but it's a session cookie, which is kind of strange because we haven't completed our login, but our session cookie has already been set, which technically means we're already logged in. So we could go and look for our 4-digit security code and put that in, but we're going to test the theory that we're already logged in by going back to our lab home. So click on back to lab home, and then we're going to try to click on my account again to see if we go back to the login page. So we click on my account. And we see that in my account that we're already logged in and that we bypassed the 2FA mechanism. So what does this mean? This means that the 2FA mechanism assigned us a session cookie when we completed the first half of the login process, probably because they didn't want unauthenticated sessions to be able to access the 2FA login page, but they did it in an insecure way in which they just gave you a session cookie, which means that you're logged in before completing the 2FA portion, which is kind of silly. So this is a very short lab. What we're going to do is we're going to test our theory by logging out. So we're going to log out. And we're going to try to log in as our victim user, which is Carlos. So we're going to go back to the My Account page. And in the username, we're going to supply Carlos, and we know his password is Montoya. Montoya, M-O-N-T-O-Y-A. I'm going to log in. So it's going to ask us for a 4-digit security code. And the 4-digit security code, you can actually get it by access, if you had access to the user account's email, which we only have for our default user. But since we know that, that the 2FA function can be bypassed, we're going to go back to our lab home, and we're going to click on My Account to log in to Carlos's My Account page. And that's the end of that lab. So everybody, if you managed to get to that point, please type, "That was easy," in chat. Rustum says, and then the guy who implemented this 2FA gets fired. Maybe they might get a talking to. So yeah. So I think that this kind of error can occur when developing apps because someone doesn't want a non-authenticated session to access the 2FA login page, which on this app is login 2, as opposed to just login. But it could have been done in a different way. So there might be a token that's assigned after you finish the first part of the login that only gives that only gives you access to the 2FA login page. But I haven't been involved in the development of 2FA functions inside of web apps. If anybody else has some insight as to how this particular app could be better secured, you please unmute yourself and give your 2 cents now. Dana says, "You'd be surprised at poor app logic. There's a whole category in OWASP top 10 for this, identification and authentication failures." In my brief history of testing apps, there were some surprising vulnerabilities that I found in the apps that I was testing. But yeah, so we're finished. We're finished with this second lab. So let's move on. Let's move on to the third lab. So yeah. So the third lab. Let's see what we're dealing with. So the third lab is the lab password reset broken logic lab. So I'm going to paste the link for this one in the chat now. And then I'm going to okay, so let's read the description for this lab. So this lab's password reset functionality is vulnerable. To solve this lab, reset Carlos's password, then log in and access his My Account page. So we're given our own set of credentials right here, Wiener Peter, and we're given the victim user's username, which is Carlos. Okay, so before we access the lab, let's flush our HTTP history. So we go to the proxy HTTP history here, click on one of these, and then right click. And then we're going to clear history, which is this item right here. So clear history, say yes. And then we're going to click access the lab. Okay, so before we go on, we're going to grab our URL for this lab, and we're going to copy that, and then we're going to go to target scope. We're going to remove our old lab, and then we're going to add the URL for our new lab, and we're going to click OK. All right. So, so the password reset broken logic, the password reset function in this lab has faulty logic. So we're going to go to My Account, and then we're going to try a password reset. So forgot password. So from My Account, we're going to click on Forgot Password. And then we're going to enter our username, which we know is Wiener. So Wiener, and then we're going to click on the Submit button. And then it's going to tell us to check my email for a reset password link. Okay, so we have access to an email client in this lab right over here. So we're going to click on the email client. And so we got an email that says, please follow the link below to reset your password. So we're going to click on the link over here. And it's going to take us to a web page called Forgot Password. So Forgot Password, and it's going to give a parameter, temp forgot password token, and this. Okay, so let's try resetting our password. So I'm very secure, so I always type in my new password as password. Oops, password. That's secure, right? Password, and then I'm going to hit submit. And then it's going to redirect us to the lab homepage. Okay, so if we go to My Account, and then we log in as Wiener, and we submit a password as password or whatever you set the password as, and we log in. Okay, we can see that the reset password, the password reset worked. Okay, so let's take a look at the password reset request inside of our Burp HTTP history. So we're going to go to Burp proxy here, and then we're going to sort by method, and we want to get the post method. So if we click on post and forgot password with the temp forgot password parameter, we can see here in the request that that we passed in temp forgot password token over here, right? And then we passed our username, and we passed our new password, and then the confirmation of the new password. But we passed in our username. So if we were to pass in a username not of Wiener, but of Carlos, would we reset Carlos's password instead? Well, we can test that theory out by right-clicking over here, and we're going to send this to what Dana has identified as the burp repeater. So the burp repeater is used for repeating requests that we've sent before. So we're going to send this to the repeater. So right-click, send to repeater, and then inside of burp, we're going to go to the repeater tab, which is over here beside the intruder. And so this is the exact request that we use to reset our password. So we're going to see what happens if we edit this request and try to send it again. So over here for the username parameter, instead of supplying the username Wiener, we're going to supply the username Carlos. So we edit this and we give it the username Carlos, and then we're going to send it. And the response from the server says 302 found. So if you remember from when we successfully reset our password in the web browser, that after we reset the password, it redirected us to the homepage of the app. And this 302 code says that it's redirected us. So let's see if we've actually successfully reset Carlos's password to the password. So we're going to go back here. We're going to log out. And then we're going to go back to the My Account page. And then we're going to plug in the username Carlos. And we're going to put in the password, like what we sent over here. So we click on login. And lo and behold, we have logged in as Carlos because we managed to reset Carlos's password. So everybody, if you got the congratulations, you saw the lab message, please type in reset Carlos in the chat. So Dana says, very bad design, although you could have done a post intercept, caught the post, and changed it to use the reset token only one time. I did a little, okay. Oh, Amaran also says, not only can you forget the username, it also doesn't invalidate the reset token that was already used once. So
Forge not forget.
Yeah,
Forge the username.
I did a little bit of testing on this lab, and it turns out that the password reset token actually can only be used once per username. So if you try to reset Wiener's password more than once with this token, it'll say that the token is invalid. But if you try to reset a bunch of different users with the same token once each, you can do that. So it's actually pretty funny.
Yeah, what I was saying there is that you could actually set up Burp to intercept the post itself, and you can then change it in the original post so that you would have only actually ever used the reset token once.
Yeah, of course. I mean, you're getting the reset token. You don't need to use it on your account and then on the account that you want to get access to.
Yeah.
It's I mean,
you have to get the actual reset link. So like there's some out of bound methodology to have to get that link to do that.
Yeah. But still, you would expect that to like the application to allow the use of the reset token only once. Like once it's used, it should be invalidated.
Yep. I didn't realize that what Kevin was saying there though is that they had some logic so it could only be used on one account one time. That just seems odd. Yeah, but again, bad app logic, right? You just never know.
Yeah, I've actually come across like a few different apps where password reset tokens could be used multiple times to reset the user's password multiple times while the token was still valid. And that's actually a pretty, yeah, that's also not a great practice, because you want to have those reset tokens expire as soon as they've been used once. All right, so everybody, let's move on. Let's move on to the next lab. So that was lab 3. We're flying through these. What time is it right now? Okay, well, it's already been an hour, so maybe. Okay, so this is lab 4, right? Okay, so this is going to be lab username enumeration via subtly different responses. Hopefully this link works. Oh, geez. Okay, it looks like we're going to have to, when you paste it in, please make sure that there's no space between the dash in subtly and different responses right there. So subtly different responses. Where is the? There might be an error in this link. Yeah. If somebody could paste the correct link, what is the source of this? What is the source of this link not working? Okay, so Amaran has pasted another link. Okay. So we're actually progressing past the beginner labs and we're going into the practitioner labs. These ones are slightly more difficult to do than the previous labs. Let's read the description for this lab. So this lab is subtly vulnerable to username enumeration and password brute force attacks. It has an account with a predictable username and password, which can be found in the following word lists. So these are the same username lists and password lists that we used in the previous lab. So we'll get to those a little later. It says to solve the lab, enumerate a valid username, brute force this user's password, and access their account page. Okay, so before we access the lab, we're going to reset our lab environment over here by going to the proxy HTTP history. We're going to right-click on the requests, and we're going to clear the history, which is this option right here. And then we're going to start our lab instance, access the lab. Okay, and then we're going to copy our lab URL. And we're going to go to target, scope. We're going to remove the old lab. And we're going to add the new lab. And we click OK. Okay, so what are we doing again? We're trying to brute force the username and the password. So what we need to do is we need to go to the My Account page. And we need to get ourselves a baseline failed login attempt. So username, test username, and password test password. And then we'll attempt to log in. It will say invalid username or password. Okay, that's fine. We're going to go to the proxy in Burp Suite, proxy HTTP history. And we're going to go to the post login request over here. And then we're going to right click it and send it to the intruder. And then we're going to click on the intruder. And we see that we have our payload positions here. We've got 3 of them, but we're only interested in the username. So we're going to click on clear. And then we're going to highlight test username. And then we're going to click add. But we're going to do something different. So there was a very specific error message, which was returned to us when we when we got our incorrect when in our failed login request. So what we're going to do is we're going to look for that when we do our attack. We're going to go to the options tab over here. So in the options tab, we're going to scroll down and we're going to look for a grep extract, the heading grep extract right here. And then we're going to click on add. So in each one of these requests, we're going to look for a specific response text. So in the window that appears here, we're going to look for the message invalid username or password. So highlight all of this. So invalid username or password, including the period right here. And then after we've done that, after we've highlighted it, we're going to click OK. So this is going, why we're doing this is going to become apparent after we've started our attack. So we haven't defined our payloads yet. So we're going to click back on payloads here. And what we want to do is we want to get the list of usernames. So we're going to go to the usernames list. I think this is it. I'm going to paste this. I'm going to paste this in chat just in case you don't have access to it right now. But we're going to copy all of these, copy them, and we're going to paste it in. And after we pasted it in, and we make sure our position is set over here, we make sure our payloads are set over here, and we make sure that we decided to get the error message over here from grep extract. And after we've set that all up, we click on Start Attack. And it'll say that Burp Suite, this is Community Edition, that's okay. And now we're attacking. Okay, so everybody, if you're attacking now, please type in chat, attacking now. So why did we bother grabbing that error message? Well, it turns out that what we're looking for is a very subtle change in the error message between the valid user, between valid users and invalid users. So click on the warning right here. So we're looking for a very subtle change in the error message that appears over here. So I don't see it yet. So everybody, if you've identified what is different with the error message between the between the valid and invalid users, please type what you think the difference is in the chat right now. Okay, Dana is on it. Okay, so the password, so it turns out that there's a very, very small change in the error message between valid and invalid users, in that valid users will have this message right here, invalid username or password, which is what you want to do in your error message, only they've forgotten to make it consistent with the message for invalid usernames, and that there's a period at the end of this error message. But for the valid user name, there's no period at the end of this error message, which is actually something that could happen because you have to code those two instances separately. It could be that that this typo made it into production, and it's actually very hard to spot. But if you've managed to identify the username that has the flawed error message, please spell out the word period in chat. It might take a while because there are 100 requests, and I've only gotten to number 67. So we'll probably wait for another minute or so. If you have not gotten the correct username yet, please type "not yet" in chat. Okay, so Dana says this is where compare is a great tool if you have an invalid login sequences. You can look through it and call it out. Yeah, Dana, I've never actually used the comparer before. There are like quite a few features in Burp Suite that I've simply never touched, even though I've done like a little bit of security testing on web apps myself using Burp Suite.
Yeah, so when you're in your proxy log, do one login that's got one way, one that's the other, and then you just highlight those two posts, right-click and say compare responses. Now, of course, the responses are always going to be different because there's timestamps and other things, but it calls out what's differed, and then you can use that to see what we're changing behaviors. But of course, you have to have a valid login to be able to see the difference, right? So, but you do have that because you have Carlos and you have Wiener. So
in this lab we don't.
Oh, okay. So in that scenario, you would have to have a successful login to be able to compare the two. So like you normally in a site, it would be like you would sign up for an account, see the difference. And
yeah,
but that's what compare is for. Compare can actually compare tons of different payloads for you. It's just a more intelligent diff tool, basically.
Yes, it's definitely something I'm gonna have to learn how to use in the future. Like I said before, I've never actually used the compare tool in Burp Suite before, but thank you very much, Dana, for pointing that out. But yeah, so everybody, if so I guess I'll ask Rustam and Mark. Rustam and Mark, did you manage to get your periods? Rustam is still scanning. And Mark got his. Okay, so we'll wait about another 30 seconds. Mine isn't actually done with its attack yet, so there's maybe 4 more to go. But yeah, like I said, it is very possible that this kind of typo could appear. Yeah, it's possible, but I would figure that most of these error messages are being copy pasted, and so that leaves. Well, when you're highlighting text to copy, you might actually leave out the period on one error message when you're pasting into another. So that it's actually quite realistic, I think. Okay, so everybody. So Rustam, I hope you managed to get your username in the next little bit, but we're gonna move on. So yeah, it's hard to see. What you want to do is you want to click on the offending payload there, and we're gonna right click and we're gonna send that to Intruder again. Rustam says they put it on 100 for him. Oh, well, that's very unfortunate. Okay, so after we send this to the Intruder again, we want to clear this again, and this time because we're looking for the password. So we've got the username; it's whatever showed up for you, and then we want to highlight the password parameter value, and we're going to click on Add, like we did before. And we want to go to Payloads. So from the Positions tab to the Payload tab, we're going to copy the list of passwords. Okay, I'll paste that link in chat again for you. So we're going to copy this list of passwords, and we're going to paste it in. And then after our positions is okay, and our payloads are okay, we're going to click on Start Attack. And click OK. Dana F asks, did you set your username? Yeah, and so I sent that particular username request to the intruder, so it should be the correct username. So if you're currently attacking the password, please type password attack. So I'm pretty sure in this lab, when we attack the password, we're looking for a 302 status again. So we can sort by status, and eventually one of these passwords with the correct username is going to give us our 302 status. Okay, so while we're waiting for all this stuff to come back, if anybody has any comments or any questions, feel free to ask them right now. So this attack might go on for another minute or two. It's so Dana says, if you use the same intruder session, you need to do that. If you sent the results to the new one, then it's pre-filled in for you. Yeah. So that's the convenience of highlighting the exact request that got the response you wanted, and then sending that one to the intruder again. Okay, Harshan is in. I also look forward to being in at some point, but it looks like Burp Suite Community Edition is taking its sweet old time. Okay, Dana has given it's called the Jolly Roger. Alex is in. Okay, I'm in. Okay, so I see here that I've gotten my password of Michelle over here. If I scroll down here, so I see that I am Adsel, and Michelle. So I'm going to go to my web app and go Adsel and Michelle and log in. And then I've solved the lab over here. So everybody, if you managed to solve the lab, please type in Victory with an L instead of an R. Mark Cohen says, Adsel, that's likely before your time. Well, I don't recognize that. Mark, we might have a little bit of time for everybody to catch up. If you could explain to us what Adsel is. He says it's asymmetric digital subscriber line. I have no idea what that is. Is that a type of internet? Slow internets. Nice. Oh, ADSL. Okay, sorry. I was Adsel. Okay. Sorry. I actually knew that what it was. Okay, so everybody, if you need us to wait a little bit for you, please type in "wait for me" in chat. Okay, so like I said, the security in this lab was very subtle. There's only the difference of a period in the failed login messages between valid and invalid usernames. This would be very difficult for people to spot out in the wild, but it pays to have an eye for these kind of things. People who are working in the cybersecurity industry, there's often a big payoff for people who have an eye for little details like this. Mark Cohen says, still waiting, no need to wait for me. Thank you very much, Mark. Let's move on to the fifth lab of tonight. Hopefully we can finish everything by, well, it's going to be tough finishing by 8 o'clock, but this is the link for the next lab. Oh no. Oh no, this looks like another broken link. Man. Okay, let me, so what is the problem in these pasted links that is, that's breaking? If anybody knows, could you type it in chat? Carriage return, okay, okay. Right, right, okay. Yeah, that's, okay, so everybody, let's missing dash and a line feed. Oh, okay, okay, yeah, yeah. Now, hopefully there's hopefully the last two labs don't have this problem in the links. Okay, so let's cover our fifth lab of tonight. This is the username enumeration via response timing. So this one's a little bit tricky. It says this lab is vulnerable to username enumeration using its response times. To solve the lab, enumerate a valid username, brute force this user's password, and then access their account page. Dana says, all good, we're here, we got your back. Thank you very much, Dana. I appreciate the support. So in this lab, we've been provided with our own credentials, Wiener Peter, and we're also given a hint. So the hint is, to add to the challenge, this lab also implements a form of IP-based brute force protection. However, this can be easily bypassed by manipulating HTTP request headers. Okay, so everybody, before we access the lab, let's get rid of these intruder attack windows, and then let's go to our proxy HTTP history, and then let's clear the history over here, and then we're going to go to our target tab, and we're going to remove the old lab. And then we're going to start the new lab. Okay, so it's all just a look away. Right, so the first thing we're going to do is we're going to grab our URL over up here, and we're going to add that to our target scope. So we're going to add, and then paste it in, and click OK. And then we're going to attempt to log in. Username enumeration by response timing. Okay. So we're going to try to log in. And then we're going to supply a false username and password. So we're going to do our good old test username and test password, and we're going to try to log in. And then we're going to take a look at what we've got in our HTTP history. So in proxy HTTP history, we're going to look at our post request. Okay, and then we're going to send it to the intruder. So right click and then send to intruder. Okay, so what we're going to do is we're going to do a slightly different intruder attack for this lab. Like as usual, we're going to clear everything. And as usual, we're going to add our test username as we're going to add our test username as a physician. Click add, But what we're also going to do is because we're testing for response times, what we want to do is we want to add a lot of very large string for the server to interpret. So what we can do is we can tack this onto our password. So we're going to make our password a very long string. So in the guide, I've included a bunch of A's that we can tack onto this. And I'll just type this in the chat so you can tack it on if you want to do it for yourself. Oh, okay. This is not all on the same line. So everybody, if you decide to cut and paste from what I put in chat, what I want you to do is I want you to go into the string and make sure that it's all on a single line and that none of the A's are on the next line. You'll know that they're on the next line because they'll be on the next line and they'll also be colored in blue. Another thing we're going to need to do when we attack this particular lab environment is we're going to have to add an extra HTTP parameter to our request so that we can spoof our IP address. Because you can see over here, if we just try to spam a bunch of incorrect requests, eventually it'll say you have made too many incorrect login attempts. Please try again in 30 minutes. Oh, geez. That's no good. Ryan Clark says, I gotta say, Kevin, I appreciate your workshops a ton, always mean a lot, but I also love that you just crush through any gotchas and make it happen aligns with my workflow. Ryan, thank you very much. I'm trying my best. So what we can do is we can spoof our IP address when we're making these requests to circumvent this brute force protection by supplying the H exported for request header, and we're going to set that to a value for numbers. So numbers, and we're going to also add that as a position. So this is X forwarded for. Oh wait, it's not X forwarded for. Okay. So I'm going to paste that in chat. I'm pretty sure that's the correct spelling. Okay. So we're also another thing that's going to be different about this attack is that we're not using a sniper attack. What we're going to do, a sniper attack does the same payload for every one of these positions. So numbers would have the same payload and the username would have the same payload. What we want to do is we want to perform what is called a pitchfork attack. So a pitchfork attack uses separate payloads for each position. So numbers would have its own payloads and test username would have its own payloads. So set your attack to pitchfork, and then we're going to move on to the payloads. So then click on payloads. Payload set 1, this is for the numbers. The numbers for our exported for header. So we're going to switch from the simple list, and what we're going to do is we're going to supply numbers. So payload 1 is numbers. We're going to do sequential from 000 to 000 to 100 with a step of 1. And then for payload 2, we're going to go from payload set 1 to payload set 2. And this is going to be our simple list. And we're using our usernames. So once again, I'll paste that in chat just in case we need to use it. And then we will copy our usernames and paste it in. Okay. And so after we've set our attack type to pitchfork, and we've set our exported for HTTP header and given a position to it, and then given a position to our test username, and supplied the payload set 1 as numbers, 000 to 100 with a step of 1, and oops. And payload set 2 is our usernames, then we're ready to attack. Okay, so click on Start Attack and click OK. Okay, so that was a bit more setup than we're used to. But if you're attacking, please type attacking in the chat. So another difference between this attack and our other attacks for usernames is that we're going to try to find response timing from the server. So what we can do in our attack window is we're going to click on this columns option here, and we're going to click on response received, and we're also going to click on response completed, that will make these columns appear inside of our attack window. And what we can do is we can click on response received, and eventually we're going to see one of these payloads with response received that is much higher than these other ones. And so why is this? This is because there are a lot of servers. There are a lot of web apps that are designed to only process a login request if the username is valid, and so usernames that are not valid, they're not going to be processed, which means that the server is going to take more time to respond to those particular requests. And this is actually a very common issue in application login pages. So everybody, if you've managed to get your extra big response in the intruder attack, please type in long attack in the chat. A bit premature on mine because I haven't actually gotten a long attack. Okay, so we have 1, 2, 3, 4, 5. Okay, so I'm glad to see that there's so many people still hanging in here with these labs after all this time. I'm sad when I start a workshop with a great number of students, and then one by one they get bogged down in some detail or another, and they drop out. But I'm glad to see the people who are sticking with it. There we go. Okay, so we've got one response over here that is extra long compared to the other ones. If you haven't received your payload with the long response, please type in waiting for long in chat. Dana says, Kev, can I ask why you thought to use a base 10 numeric for X44 rather than doing IP using something like number 1.2.3 point number? Upstream errors and firewalls would drop that if it was invalid IP. Dana, that's very valid. That's actually a good call out on me being lazy. Normally I would, I would make up some sort of imaginary IP address and iterate through that instead of just providing a straight number. But I was being a bit lazy when I was writing up the guide for this, and I found that that just iterating through numbers worked on this particular lab. So that's the way I did it. Okay. Thanks, Anna. Okay. So anybody else still waiting for long? If not, we'll skip over to the second part of our attack. So what I want you to do is I want you to highlight the request that got the long response, and then I'm going to have you send it to the intruder again. So, and in the new intruder window, we're going to keep using the pitchfork attack. So what I need you to do is I want you to switch over to pitchfork again. I want you to clear everything here. X-forwarded 4, we're going to set this as numbers again, and we're going to have to set this again. We're going to add that there. So X-forwarded 4 is a position, and the username is that, and the password. Well, we're attacking the password now. So what I want you to do is delete what you had for the password previously, and just put test password there. You could put anything for it really, but what you need to do is you need to add it as a position. So X-forwarded 4, remember to include that, add that as a position. Username is whatever you found. Password is also a position. Rustam says, sorry I was distracted. Is video recording available later? Yeah. So we're recording this broadcast. It should be available on our YouTube channel within the next week, if I'm keen enough to get started on it as soon as it's available. Okay, so yeah, so this is pitchfork. X-forwarded 4 is numbers. Password is a position here. Payloads. Password set 1 is numbers, and set that to sequential from, actually first, yeah, so numbers, it's 000 to 100 with a step of 1. And payload set 2 is passwords. So it's passwords, it's these passwords. Let me paste that in chat. And let me copy this and paste. Okay, so I think that's it. So payload 2 is our passwords. Payload 1 is our numbers. Positions, we have X-forwarded 4 and password here, and we're ready to attack. So attack type is pitchfork. Let's start the attack. If you are attacking, please type attack the password in chat. And as usual, like we did last time, we're going to get the actually, no. We don't need to get response times, so we don't need to go here. So what we do need is we're looking for, are we looking for status again? Yeah, we're looking for our 302 status. So click on the status column, and eventually we're going to get one that's going to be the 302 status. Dan is done. I'm not surprised. The power of Pro, that's true. That's true. Dan is using Pro, so his attacks go through super fast. But yeah, we can so we can talk about we can talk a little bit about the vulnerability in this lab. So the vulnerability in this lab is that the lab doesn't process login requests if the username is not valid. which is which saves on server load, but it also makes it so that any malicious users could potentially enumerate usernames by seeing which response times come back a lot longer than other invalid username requests. Oh man, there's typos in my TDF. Oh well. Okay, so I've got my 302 status here. Everybody, if you're still waiting on yours, please type in waiting for mine in chat. Because yeah, the attack is going to take another minute or two. Matt says victory. Alex is waiting for his. But yeah, while we're waiting, I'm just going to take my username of, is that Appy or Apple or App1? I'm just gonna highlight it and paste it in, and then the password is Michelle. Oh wait, it's not gonna let me do it because I have to wait 30 minutes. Yeah, wow. So I've kind of owned myself by demonstrating for you guys the lockout method.
You can add X44 to your request from the browser.
Oh yeah, that would be done with the developer tools, right?
No, I think you can, because all of your requests go through Burp. You can add a header in Burp. I think it's in the proxy options.
Yeah. No. I think I know what you're talking about. Okay. So I can do this. I can type in Michelle, right? And in my proxy, I can go to intercept and I can actually turn it on.
Yeah, you can do that, or you can go into options and like you can set rules to add content to all of the requests that go through proxy.
Oh yeah, okay. But yeah, so I'm going to click on login, and it's going to. So I'm going to manually add my exported 4,000.
So don't send that yet. Don't send that yet. So this is what I thought. Someone else had asked in the chat. You know, they wanted to see when I was talking about intercepting the post to change the username. This is exactly what that is. When you have the intercept on, you can get it either on the sending or on the receiving coming back from the server, so that you could do things like adjust cookies that are being set. And that's one of the biggest powers of Burp that not a lot of people use, is actually intercepting to modify in-flight requests. So even before the browser gets it or sends it, this is what's going to be fired down the wire. And that's a very powerful feature of what Burp can do to really manipulate things that aren't supposed to be manipulated. Yeah, and intercept is it's useful for requests that are very sensitive, and that they can't be repeated because for one reason or another it's not going to work if you repeat the request, like those password reset tokens, which can only be used once. So those are the type of requests that you want to intercept, as opposed to going to the HTTP history and grabbing it from there and repeating it from there. But yeah, I can forward this, and then I'll turn intercept off, and then I've logged in and I've bypassed the IP lockout. Okay, so everybody, if you've managed to successfully solve the lab, please type solved in chat. And we can move on to the last lab. Wait, are we on the last lab? Oh, geez, but we only have 5 minutes left. Is everybody, are you okay for sticking around? I understand if people got to leave.
I think we should finish. The recording will be available later if somebody needs to drop, they will.
Okay, okay. So yeah, we're gonna move on to Lab 7. Lab 7 is username via account lock lab. Did I skip one?
Yeah, I thought there was 2 left.
Oh, wait. Yeah. No. Yeah. There's. Oh, geez. We're gonna go way over time. Okay. But yeah, okay. This lab is lab 6. Lab 6 is broken brute force protection IP block, and it should be this. Oh, Dana's got me. Thanks, Dana. Okay. So what are we doing in this lab? It says this lab is vulnerable due to the logic flaw in its password brute force protection. This is actually an interesting lab. To solve this lab, brute force the victim's password, then log in and access their account page. We've been given our own credentials, Wiener, Peter, and we've been given the victim user account name, which is Carlos. Josh D has got to head out. Thanks for coming, Josh D. Catch you next time. Let's see. Okay. So advanced users may want to solve this lab by using the macro or tuber and intruder extensions. However, it's possible to solve the lab without using these advanced features. There's a trick. There's a trick to solving this lab when you're using the community edition of Burp Suite, but we'll cross that bridge when we get there. So the first thing we want to do is we want to clear our lab environment. So we're going to go to HTTP history, and then we're going to clear history. And then we're going to start the lab. And then we're going to grab the URL and go to our target scope, remove the old one, add the new one. Okay. And then we're going to go to the My Account. And we're going to give our baseline failed login attempt, which is test username and test password. Okay, that's invalid. We're going to, Max also has to drop. Thank you for coming, Max. Yeah, hope to see you at the next one. So we're going to go to the post request to log in, and we're going to send that to Intruder. And then we go to Intruder. And so let's see. Okay. So what we also need to do is we need to figure out that there is a lockout for usernames so if we send Carlos like a bunch of times, it'll say you have made too many incorrect login attempts. Please try again in 1 minute. This means that the lockout in this app is not by IP, but it's by specific user account. So the specific user account can't log in after too many attempts. But there's a flaw in the logic here, in that if we log in as Wiener and we supply correct login credentials. Oh, Wiener Peter. Oh, okay. So what we need, so I'll explain what's going on with this lab. So we can't, so there's a lockout in place if we attempt, I think it was if we do 3 incorrect logins as a particular user, then it'll lock you out. But if you do 2 incorrect logins and then a correct login, then the incorrect login counter is reset, and then you can send another up to 2 incorrect logins and then send correct login. So we can set this up in the Burp Suite Intruder, but it's a little bit tricky. So let's go to our so if you haven't already, so the login request, we're going to send that to Intruder, and then we're going to clear all of our positions, and then we're going to set up. We're going to do 2 positions. There is so we're going to add the username, and then we're going to add the password. And we're going to set this up as not a sniper attack, but as a pitchfork attack. I'm pretty sure we want to set it up as a pitchfork attack. Let me take a look at my notes. Yeah. So we're doing a pitchfork attack, but in payloads, payload set 1 is going to be our usernames. So we know that we get a reset. If we reset the login counter by providing a correct login, we can bypass the lockout mechanism. What I have is a custom list of usernames and passwords that is going to work for this lab. So I'll paste them in chat now. So this is the usernames list. And if you go there and you go to the raw, then you can copy this list, and you can use this as payload 1. Payload set 1, paste this in. So it starts with Wiener, Carlos, and then Wiener again, and then it repeats that like 150 times. So for payload set 2, this is going to be our passwords. And there's also a custom list that I made for the passwords. And I'll paste this in chat now. So this is going to start with the correct. So every third login is going to have a correct login with the Wiener Peter account, and then it's going to try a couple of random passwords to see which one is correct. So it's like I said, it's a pitchfork attack with the username and the password as the positions. The payload 1 is the custom username list, and payload 2 is the custom password list. So this is where it's a bit tricky to get this to work on the community edition, which is normally really slow. We're going to start 4 attacks at the same time. So what I want you to do is I want you to click start attack and then OK 4 times in quick succession. So start attack, OK, start attack, OK, start attack, OK, and then start attack, OK. So this is a hack to get around the slow speeds of this is a hack to get around the slow speeds of Burp Suite Community Edition, because otherwise we wouldn't be able to do this. So if you're attacking right now, please type attacking in chat now. Oh no, wait. Oh, I forgot. Sorry guys. I want you to stop your attacks. Stop your attacks. There's one thing that I forgot to tell you guys. The last thing that we have to do before we start our attacks we need to go to the resource pool. We need to go to the resource pool, and we got to make sure that that the resource pool only has a number of maximum concurrent requests equal to 1, which means that it's going to go through. And Dana says this is going to cause collisions you need to set to 1 at a time. Yeah, Dana's correct. I forgot to tell you guys. We need to set maximum concurrent requests to 1, so that we're going in order, so that it all goes according to plan. Sorry guys. So everything as it was before, but set your new resource pool maximum concurrent requests to 1, and then we're good to go. So then you can do your 4 attacks in a row. So start attack, okay. Start attack, okay. Start attack, okay. Start attack, okay. Okay, so sorry guys. So Dana says, otherwise the threading will happen out of order, and now Pro isn't as fast. Lol. Yeah. I think the people who are using Pro also had an issue with this lab, and they had to set their, I think they had to set their number of threads to something larger in order to get this to go off properly. Okay, so everybody, if you're attacking, please type attacking. Dana got it in a couple seconds, okay. Okay, so everybody, so what we're looking for is we're looking for a status 302. Wait. Why am I not getting status 302? Everybody, is everybody else getting status 200 for everything? You should be getting status 302 for these valid, okay, now the 302s are coming in. That's weird. It's weird why they weren't coming in before. Oh, the server's out of sync. Okay. It's because I fired off 4 sessions. Okay, so what we're looking for is we're looking for a status 302 with payload 1 is Carlos. So this might take a while because we're doing more requests than usual. We're doing 150 instead of our regular 100. So everybody, please tell me if you've managed to get your 302 for one of Carlos's. Yeah, type in chat, Carlos win, if you manage to get it. Yan says I have to drop. Thank you very much for coming, Yan. Dana got it. Yeah, this might be a bit slow, but Dana says he only launched 1 session though with 1 request in the resource pool. Yeah, hopefully I didn't muck this one up. Yeah, create new resource pool, maximum concurrent requests 1. Oh, could it be? Yeah, all these are the ones that are also 200s. Okay. Hey guys. Mark Cohen says, how is launching 4 attacks speeding this up? And Dana says, I think when you launch multiple sessions, it's not in the right order, so the logic for the loser lockout isn't consistent. So Mark asks, how is launching 4 attacks speeding this up? Well, it's speeding this up because normally, the process for solving this lab is to send 4 of the same requests, followed by 4 of the same requests. So the same request is sent 4 times in a row to see which one to see which one to see which, sorry, let me gather my thoughts. To see which one locks out. To see which one locks out. If you send Carlos, did I screw this up? If I send Carlos with the right password, if I send Carlos with the wrong password, it's not going to lock out. But if I send Carlos with the right, sorry.
The logic looked like what you showed there. The way that I understand this was that if you send a failed request 3 times, you get locked out. So your patterns of your username list is you're going to send 2 for Carlos, and then you try your real target, right? So you're resetting it. Right. So like if you look at your username list and your password list, right, you've matched it so that there's successful login for Wiener.
Yeah. Yeah.
Right. So then you can try 2 failed requests. Then you log in as Wiener again to reset the counter so that you'll never be in a state where you get blocked. So for that to work successfully, you should only run 1 of these. That's why in your resource pool, you're saying send 1 at a time. So it's not multi-threaded, so you could get the proper count. So the server's looking at it and saying, failed login, success. Okay, reset. Failed login, success, reset. And so that way you're doing 3 requests to actually test 1 password, which makes sense. Oh, sorry. Yeah, 3 requests. No, 2 to 1, sorry. So you're going to test 2 potentially bad passwords, and then you got to reset with a successful one.
Oh,
so
you know what? No, I screwed this. Sorry guys. I screwed this up. You're not supposed to, the sending multiple requests, the sending multiple attacks to get the request is supposed to be for the next lab.
Okay.
I'm actually really sorry about this, guys.
That's okay.
So let's
just take one and close the other 3, reset, and just rerun it. Now you may need to just do one because you want to get in a clean state because you want to make sure you're not in a weird state when you start it. Does that make sense?
Yeah. So yeah, I'm gonna reset my lab, and well, let's see. Can I reset my lab environment?
Yeah, you could probably just leave it and then go and go to it again. It'll create a whole new session for you.
You can wait a minute, but the lockout is really short.
Let me grab that.
So the premise is there for anyone who wants to just redo that. Kill all your sessions, your intruder sessions, except 1. And then just follow what he had on there, right? So load the list, the 2 lists up, set your resource pool to have only 1 concurrent request. So it's not multi-threaded. So it's going to be in the order that you sent it. So there'll be 150 requests that are going to get sent out. And then just wait and it should work.
Okay, so let's see if Wiener Peter works. Okay. My proxy is not going to work with this. Okay, so I got to clear this. I got to clear this out. And then I have to go to target scope and then remove this lab environment and then put in a new one. My account, and then we'll give a false one, Carlos and something. Okay, and then we're gonna go back to our proxy. Send it to the intruder. I'm gonna do this, again. We're, once again, we're doing a particular attack. And then it's not Carlos, wait. Well, so it says Carlos password. It doesn't actually matter for these positions what's in between the position markers. It's just important that something's there. And then we're going to go to our payloads. Actually, we're going to configure the resource pool first. So the resource pool is going to have a maximum number of requests to 1. And then payloads is one is the custom usernames list. And paste it in. And 2 is the custom passwords list. And then we're going to start our attack. And we're looking for status 302 for Carlos. Okay. Okay, so this should be the way. this should be the way. Sorry for screwing that up, guys. I got my wires crossed. Mark's going to drop. Thank you for coming, Mark. So everybody who's sticking with us, when you get the Carlos 302 status, please type in Carlos 302 in chat. Yeah, like I said, this is going to take this might take longer than usual because we're sending 150 requests instead of our usual 100, and 100 was already a bit slow, so 150 is going to be a bit more painful. But thank you very much for your patience, everyone. So while we're doing this attack, let's go over what is vulnerable in this particular lab environment. So Lab's web app has a logic flaw in its anti-brute forcing function. The function is supposed to lock out and prevent logins from a particular IP if there are 3 failed login attempts from the same IP address in a short amount of time. However, a successful login from the same IP address would reset the number of failed login attempts for that IP address. So this enables brute force username and password attacks if a set of valid credentials is available. So if you're able to sign up for a particular web app, then whatever whatever set of credentials that you signed up with, those would be valid credentials, and you could do brute force attacks on the app for usernames and or passwords if this is the way that the app is set up. So this issue could be resolved by eliminating the reset of the failed login counter when a successful login occurs from any given IP address. So whatever function that is that resets the failed login counter, just remove that code and it should be fine. But although I'm not particularly sure if this would be an issue to code or if there's any particular roadblocks to prevent that kind of thing from happening, because I'm not a web app developer. If anybody has insight into this kind of thing, feel free to chime in. Dana and Alex got their Carlos 302. Let's see if I've gotten my Carlos 302 yet. Carlos is all 200 for me right now.
So while this is running, another way you could have done this is used a login macro, and you could have said that after 2 requests, run a login macro. And what that would do is it would always reset your environment. It's the same as what you were doing with your the way you synced up your list, but you wouldn't have to do that. You wouldn't have to generate a special list to do that. Not that it's hard, because you can just run that through quickly in Python and generate it. But macros are pretty powerful in Burp to be able to do this kind of thing, especially for things like session management, or if you need to re-auth to get to a different place, i.e. get a request and then send it to a staging server to act differently. You could actually have it all built that way in your macros. So.
Yeah. Burp macros are another thing that I really want to explore more. The next time I do a deep dive on web application vulnerabilities in Burp Suite. So can you repeat one more time, Dana, what you usually use the macros for in Burp?
Well, you can use macros for anything, but like one of the things is if you know that you have to have a successful login before you can run any other kind of attacks, as an example, you could set up a macro that could say at the beginning of every attack, intruder attack, I want to run a macro. Or you could say after 2 successful failures, run this macro. And so what ends up happening is where you created this custom username list and password list to have a successful login, you could just have that be part of the pipeline for processing. So you just have your normal username list, your normal password list, and the macro would be just a programmatic way to inject a successful login to force the IP blocked to get cleared. So these are just ways that you can accomplish the same thing. You did nothing wrong with what you did with your list. It's a way to do it, and it works. It's very simple. But when you start getting into complex things where the whole session, maybe it's more than just resetting it. There's things related to session variables and or cookies. You can use the power of that in the cookie jar to manage that, to make sure everything's clean in the attack sequence.
Yeah, yes, thank you very much for explaining that, Dana.
Yeah, and there's a macro recorder right built in. So if you look at Burp Suite, Portswigger has some videos in that to teach you how to use the recorder. It's basically the same thing you're doing when you're sending it to Intruder Net. It's just you select a sequence, say I want to generate this as a macro, and then how do I want to link it, or how do I execute the macro? So it's just nice features built into the product.
Yes, thank you again. And I'd like to ask the people who are still with us in chat, if you're still waiting on your Carlos 302, please type waiting, so that we know that you're still out there. Okay. So we've got a small crew of dedicated people out there. So I'm going to plug in my my correct credentials here, Carlos and Andrew. And that's it for this lab. Okay, let's move on to the final lab, where we can do the great little cheat that I that I demonstrated too soon. So this is lab username enumeration by account puck. Yeah, this is what I was trying to do before. And I think this link should work. Okay, so let's venture there. Oh, oh man, I have no luck. I have no luck with these. Dana comes through. Dana comes through again. Thank you very much, Dana. Okay, so let's do this. Okay, so so we go into our target scope and remove the previous lab. Oh, that link doesn't work either. Wait, yeah, no. I think I copied it wrong. Okay, so this lab is vulnerable to username enumeration. It uses account locking, but contains a logic flaw. To solve this lab, enumerate a valid username, brute force the user's password, then access their account page. Okay, so we're running late, so let's do it to it. Okay, so we're going to copy this and we're going to add this as our in-scope URL, and then we're going to get our baseline invalid login. You test using test password login. It is invalid. That's fine. Then we go to our proxy, and we're going to send it to our, we forgot to clear our history, but that's fine. We're going to send it to Intruder. We're going to clear this stuff. And what are we looking to do? We know that only valid usernames can be locked here. So we need to figure out which username is valid. So after we get our, so here we're going to do a default sniper attack, but we're going to conduct 4 of them at the same time, so that we can try to force an account lockout, and that's how we're going to figure out which username is valid. So the username position, we're going to set that. And then we're in payloads, we're going to get the usual list of usernames. And we're going to use that. And like I said before, we're going to I think, yeah, we're going to set the maximum number of threads to 1. Resource pool, maximum threads, 1. And then we're going to start our attack 4 times in order to try to get the successive requests and see if we can get the lockout on one of these user accounts. So we're going to do start attack 4 times. Start attack, okay, 1, 2, 3, 4. Okay. So we're looking at what are we looking for in the response? We're going to look for one response that is longer than the others. So in our length column, we're going to keep a lookout for the user account that comes back with a length that is longer than the others. If you're attacking right now, please type attacking. So while this attack is going on, let's discuss what exactly is wrong and what exactly is the issue with the app. So in this lab application, there's an account lockup mechanism that's linked to specific user accounts rather than IP addresses. So we found the lock mechanism can be abused to enumerate valid usernames in the app. So also the server is not coded to provide. Oh, okay, that's a spoiler. Never mind. But yeah. So the whole issue with enumerating usernames through brute force mechanisms is a bit contentious, because there's no real. I'd say that it's hard to implement a lockup mechanism that is entirely satisfactory, because you generally don't want to lock out. You don't want to lock out by username, because if people manage to find a username for a person that they just don't like, they can intentionally lock them out of the app by activating the lockout mechanism for that specific account. But doing it by IP might be a better way to go. But there are ways to circumvent IP-based lockup mechanisms. But I think that doing lockout by IP is probably the better way to go as far as app security is concerned. So I have gotten my extra long length username right here. The length is a little longer than the rest of these. And if we go to the response, we can see that that user was locked out via this message right here. You have made too many incorrect login attempts. Try again in 1 minute. Okay, so we found our correct username. So everybody, if you found your correct username, please type "found it" in chat. Okay, Dana found it. Not surprised. Dana's on it. Dana used the cluster bomb. The cluster bomb is the other way that they recommend solving this lab in the official documentation. Unfortunately, it doesn't work for the community edition of Burp. Amaran also found it. Nice. So the rest of this lab is is typical for the other lab environments. We're just going to send this back to Intruder, and then we're going to target the password with this username.
But now that we know the username, how do we avoid the lockouts?
How do we avoid the lockouts? Well, there's actually a this lab combines another feature that was in another lab, where the message was different depending on whether it was a valid combination or not. So we'll find that there's a different response message if we supply the correct password. So what you can do is just grab your typical password list and set the password as the position. In the payloads, paste it in. And in the resource pool, we don't need to, we can just use the default resource pool for this one. and then start the attack. So I think there should be a different response length for a valid response as opposed to an invalid response. So, okay. Right, so if you're attacking the password right now, please type attacking the password attack in chat. In the meantime, David says, as a dev manager, I've always been reluctant to lock out by IP because we have companies as shareholders where many staff sit behind an NAT that presents a single IP for the whole company. Any way around something like that? Let's see. I actually don't have a good answer for that, but if anybody, any other AppSec people have some insights to what David is talking about, please unmute yourself and chime in, or type in chat what your thoughts are on that. Okay, so what I found here is one request that returns a different length of message. And if we scroll down the response, instead of providing invalid username or password, the message is simply blank. So this is the method of determining which is the correct password in this lab. So we're looking for the length of message that is slightly different and has a blank response in the body of the request, of the response. Sorry. And this particular combination is alerts ABC123. So let me try that. And with that, we've solved the final lab tonight. So everybody, if you've managed to find the payload that responds with the abnormal length and has the blank response, and you've successfully logged in to the application, please type finished in chat. Dana is head of the class again. Okay, so let's finish off talking about what was the issue with this particular application. So we found that the account mechanism could be used to, the lockout mechanism could be used to enumerate valid usernames in the app. Additionally, the server was not coded to provide the same error message during the account lockout to requests with invalid passwords versus valid passwords. They returned a different message, which could have been an oversight on the developers' part, because developers they didn't expect people would be looking for this different message, and simply failed to code the same message for invalid passwords versus valid passwords after an account has been locked out. But it's certainly something that could be addressed very easily in the code after it had been identified.
Well, I mean, that makes the whole lockout mechanism basically broken, because the whole purpose of lockout mechanism is to slow down the brute force attacks. And if you have different message for correct versus incorrect password, you're not slowing down brute force attacks.
I think it might be a situation where it could be something like something a little bit like security through obscurity, where like the developer figures that anybody attempting a brute force attack would see that that they get the lockout message, and that they would give up and move on. But it's actually flawed, because the messages are different depending on whether or not the password was valid or not. Either way, either way, it's certainly a flaw. But there are instances there. I can certainly see instances where somebody would see that that there is a lockout mechanism, and they just kind of give up because they don't want to, because they figure it's impossible because there's a lockout mechanism. But then again, we've seen tonight that there are different ways of circumventing lockout mechanisms, and we've only explored a couple of them in this handful of labs. There are certainly way more of them, and way more than I honestly expected that there would be. But yeah, let's so everybody, I hope if you're still waiting on your intruder attack results, please type waiting in chat. Otherwise, if not, we'll get to the conclusion of tonight's workshop.
I want to get back to David's question. I mean, in my view, probably the IP address based lockouts are still better than username based lockouts. But basically, you need to be careful with the thresholds, because you're absolutely right, and I don't think there's much you can do about it.
Treat it like a gray list. Don't make it a permanent blacklist. Have it as a gray list, so it resets it. You can't do much about NAT. NAT's NAT, right? You can do session affinity and try to do that, but then you're breaking things like balancers and trying to just make sessions work the way they are. If you're going to block by IP, then block by IP, but relinquish it after a period of time. The goal is to slow down the brute. You can't stop it in that way.
Yeah.
That's
go
on, Amara.
No, I was going to say that also IP address based lockouts are not foolproof, meaning that like it's easy to like bounce your requests through proxies or go through Tor and whatnot, and basically bypass the IP address based lockouts. But the username based lockouts just lead to potentially denial of service for legitimate users.
I'd be interested to hear like what the right combination of lockout would be like a good like balance between usability and frustration as far as like user experience is concerned.
Defense in depth has that you should really be thinking about other things like fingerprinting the connection. So there's other attributes of the connection that you can look at. Yes, you can modify those too. Anything being sent to the server can be modified, right? But there are certain things that most attackers are too lazy to deal with. So if you start looking at things like what is their user agent? What is their actual browser fingerprint looking like? Not just outside of what they're sending, but what's coming in. You combine that together with other pieces of information, like the session information that you might have, any cookies, anything like that. You start putting together a progressive profile of the connections. And then what happens is legitimate ones may look differently or act differently. So you may, as an example, if you know a connection's coming in and it has a valid JOT that's been, you know, validated already in that session, you may allow that through, but not allow someone else who's going to the login page from that same IP who isn't already validated or doesn't look right. You know, when you think about things like conditional access policies that get applied and they look at things like the IP related stuff that might be geofenced, but then they're also going to look at the device information. They're going to look at the browser information. They're going to look at the sequence or even retry logic if there's just too many packets coming in. All those combined can then be utilized to try to filter it out. It's not perfect, but what are you trying to solve for is the question. And from there, you can decide how much defense you want to put in place. Like, it's more important to worry about that in an admin login than probably the main page that might just be trying to get some information for adding or something, right?
Yeah, yeah. But also maybe another idea could be, instead of locking out, just slowing down responses.
Yeah, well, and that's what 429 is for, right? So you can have retry logic and have a back off policies. And so most servers and frameworks themselves have the capability to be able to say, like, listen, in this session affinity, as I see you trying to hammer this, if you look like you're the same with all these other attributes on there, we will slow down the responses and or the amount of times, or will require you to do a 429 wait. And you got to wait 5 seconds, 15 seconds, 30 seconds. And that helps to just kind of dial back the flooding that could be going on there. But again, even that can be bypassed. You know, like, I've got code that allows me to spin up 99 virtual machines in Azure and then sends off the requests individually on each one. So I have a different IP every 99th request. So it's very hard to then limit that down. So I can be hammering with what looks like 99 different clients, but it's actually one session doing its work. I could do more, but I can't afford that. I can't bill a customer for spinning up more. So,
yeah, I mean, that certainly sounds like a very luxurious way to go about like brute force attacking. Like, yeah, I don't know if your typical, like, you know, hoodie wearing, you know, black hat hacker in their basement has access to that kind of computing power.
Oh, sure they do. A little combination of proxy chains and an AWS account, you can spin it up. It's ephemeral, right? You're only getting billed at the time that you're using it. So if you spin up 100 containers up in Linode or whatever, it doesn't really matter. You just need to know how to chain them together and utilize them. So,
well, all right. Thank you. Thank you for your
students that are just wanting to practice may be different. But when you're doing this for work and you're trying to, you know, you're conducting a pen test or try to accomplish something, if you know you got, like, a good example might be something like you're doing directory enumeration on a site, right? They can easily slow you down or block you because you're hammering it too quickly. So you can solve that by splitting your lookup list across multiple nodes. And so so Ferex Buster is an example. You separate them into individual nodes, and you only do a partial of it, and then you're hammering at that server with 99 different IPs. Or 100 or 20, like, you know, your scaling really comes down to what you're willing to spend. And when you're being billed by the minute, you take something that might take you 20 minutes to scan and take it down to 2 minutes. That time is worth something.
I hadn't really thought about it before like that, Dan, and thank you very much. But yeah, let's finish out.
A quick question, sorry, Kevin. Dana, you said you've used the cluster bomb for the last one. So when I tried that, it started going through the usernames first, and then the passwords. Is there a way to swap it around? Basically say, hey, what you do, username first, and then
so set your username as the first item, and then second item, do a null payload. So what you do in the cluster bomb is instead of setting it on the password, after the password, just do when you click the add, it creates that weird character. Do that twice, and then in your second payload in Burp, set it to a null payload, and then say I want to create 5 of them. So then what happens is it's going to fire off 5 requests with null payloads and allow you to see what's going on. Does that make sense?
Not quite, but I'll try.
So it's the same request being sent 5 times by the cluster bombs, because the cluster bomb is doing each iteration of all the payloads. So because one of the payloads is a null payload and it's set to 5, it'll do one payload combination 5 times and then another payload combination 5 times, and that's how we figure out what the username is. Because if you do it 5 times in a row on that particular app, it'll lock out that account.
Yeah. So basically, what you're saying, if it's a null payload for the second position, then it's gonna. So the first position is username. Yeah. You're saying you're saying add a kind of dummy first position somewhere before the username.
No.
Then
the first
after.
The first one should be your username, and then the second one should be after whatever you have as your pass. Just click on the add button twice, and it creates an empty. It's just the second one that's in there, and then when you go into your payloads, set the second one to be it's called a null payload.
Yeah,
and then generate 5
are
payloads.
You saying then it's gonna cycle? So what I did is, like, I've selected username and you did that as a first payload, and then I selected password and did that as second payload, and used like 1, 2, 3, 4 for the second payload. In which case it picked the password, the first password, like 1, and then cycled through usernames instead of picking a username and cycling through passwords. Yeah, what you're saying is if you do a null payload for the password, it's going to do different.
You don't set the password as a payload.
You don't set it as a payload at all. So the trick with the cluster bomb is that because we want to send the same user 5 times, right, to cause the lockout. Like what we're doing is we're saying, I want to try this username, and I've got 5 payloads that I want to try to use on here, which are all null. And then it'll send the first user 5 times. Then it'll send the next one and the next one. And so that just allows it to play out the way you want to. Because if you do it through the sniper, it's the 1, right? So it will go to the next one, and then the next one, and the next one.
Okay.
So yeah.
So let's do the summary for the workshop. Thank you very much for your insight, everybody. This would have been a much less interesting conversation if there weren't people chiming in with their own experiences. So what did we do today? We worked through several vulnerable web apps in the lab environments. We learned to use the Burp Intruder for brute force login attacks. We identified what aspects of the login page code may lead to vulnerabilities. From there, everybody is still here. Thank you for sticking it out. But of course, we went way over time. Where do I continue from here? Well, there are a plethora of different lab activities inside of Portsmouth Academy that you can work through at your own pace using Burp Community Edition for most of them. Portsmouth Academy is also a great source of educational resources for web app security testing. Everybody, if you have any questions right now about anything really, please feel free to unmute yourself and chime in. I am on Twitter. If you want to talk with me, You can do that on Twitter. You can do it on Slack. My name is Shy Hat there. Oh, sorry, it's not Shy Hat. It's the Shy Hat. But yeah, with that, thank you everybody for coming to today's workshop, and it was a pleasure helping you to get through the labs. I hope everybody learned something tonight, or if you didn't learn something, I hope you had fun working through these lab environments using Burp and having fun with the rest of us. Thank you very much, and yeah, I'll just open it to the floor for questions. If anybody has any questions or comments, please go ahead. And with that, I will stop sharing my screen.
Thanks, Kevin.
My pleasure.
I don't see any questions in the chat.
But yeah. Thank you to everybody who attended tonight. I know that it was a long process. Maybe I should have shaved a couple of labs off to keep it in time. But yeah, thanks to everybody for coming, and to everybody who made it to the end, thank you extra hard. Thank you, David. Thank you very much. Thank you, Dana, as well. But yeah. So with that, I guess everybody is it's been a long night. Yeah.
Yeah, there's not a lot of people left, but want to mention next month we're gonna have a sort of introduction into AWS security workshop. So join in, make sure you register on the meetup, and have a good night, everybody.
Good night, everyone.
Bye.